Hello, my name is Mr. Fontenot. I am an industrial instrumentation instructor at Sewella Technical Community College in Lake Charles, Louisiana. I myself have a degree in biomedical technology. I worked in the medical field for about 13 years, repairing and maintaining a wide variety of medical equipment. I've been teaching here at Sewella since about 2013, so I have several years of experience in the classroom as well as in the field. So today we're going to be looking at span math. Span math is a very important skill that you need to master in the field of industrial instrumentation. So we're going to look at some span math problems here today, and I'm going to show you exactly how I would like for you to do your work. I'm going to provide you with plenty of practice work so that you will be prepared for the test. Now, one thing that I'm going to ask for you to do is I want to see your work, your calculations written out on your scratch paper. And I'm going to demonstrate for you today exactly how I want that to look. So here we're going to be entering in our answers into this blank right here on our Canvas Learning Management System, LMS. And Canvas will automatically grade your assignment for you as soon as you turn it in. It'll show you what you got right and what you got wrong. But I still want you to do some work on paper because I want you to memorize all of this information that you see here below. I want you to be able to write from memory for the test the span math formula, formula number 1, span math formula, formula number 2. I want you to be able to memorize the standard milliamp range of industrial instrumentation. I want you to memorize the standard PSI range, pounds per square inch. I want you to know that industrial instrumentation runs on 24 volts DC. And as we get further into these formulas here, I want you to know that the number 1 numbers are the values given, and the number 2 numbers are the values that we're looking for. If you'll keep that in mind, you'll quickly be able to master span math, and you will find that these formulas are not that hard to remember once you've had a little time working with them. So let's get started here. Now you'll notice that we have two formulas. Formula number 1 is when I am given a percentage. If I'm given a percentage in the problem that I'm presented with, I can use formula number 1. On the other hand, if I'm looking for a percentage, or if I'm looking to go from one set of values to another set of values, I'm going to use formula number 2. And I want to remind you here that 4 to 20 milliamps is the standard range. 3 to 15 psi is the standard pneumatic air pressure used in industry for control valves. And 24 volts DC is our standard voltage. Let's look at number 1 here. What percent of the standard milliamp range does a 5.76 milliamp signal equal? Well, we'll see here that we're not given a percentage. Percentage is involved, but we're not given a percentage. We're looking for a percentage. What percent of the standard milliamp range does 5.76 milliamps signal equal? So, since I'm not given a percentage and I'm looking for a percentage, I'm going to use formula number 2. I want to break this formula down for you quickly. If you've watched my introduction to span math video, you'll know the material I'm about to cover, but I want to go over it again for you. So here on this, inside of this parentheses, you'll see that all of these numbers have a subscript. All of these values have a subscript of a 1. Over here on the other side of the multiplication sign, all of these values have a subscript of 2. we have a process variable 1, lower range variable 1, upper range variable 1, and lower range variable 1, times my upper range variable 2, my lower range variable 2, plus my lower range variable 2. And this will give me the answer I'm looking for. So the first thing that I want you to do is picture in your mind that there's a line here, kind of a line of demarcation. And on the left side of this line, on the left side of our multiplication sign, are all of our number one numbers, and our number one numbers are going to be the numbers that we are given, values that we're given. Our number two numbers, the numbers on the right side of our line of demarcation, are going to be the numbers that we're looking for, the values I'm looking for. So I've got some values I'm given, I got some values I'm looking for. If we look over here at our percentage formula, you'll see that again to the right of our multiplication sign, this is what I'm looking for. And as I said, you can only use that formula when you're given the percentage. So let's get started here. We're going to write out our problem first, and then we're going to punch the numbers into our calculator. So let's begin here. We're using formula number 2, so we're going to work underneath formula number 2. I want you to begin by drawing your parentheses. This is the way I've memorized it. It may be easier for you in some other way. We're going to draw our parentheses. We're going to put a line, times. We're going to open our parentheses here, another set of parentheses, and then plus. We don't know what it's going to be plus yet, but this is the outline of our formula. All right, so the first number I want to plug in here, if I look at my formula, the first thing I want to plug in is my process variable number 1. And these are the values I'm given. So what value was I given? Well, let's see. I'm looking for a percentage. I was given the 5.76 milliamps, and it says the standard milliamp range is 5.76 milliamps, because that's what I was given, minus my lower range value, which is 4. I know it's 4, because I'm dealing in milliamps, because I was given milliamps, over my upper range value, still dealing with the number one numbers. What is the upper range? 20 milliamps, minus the lower range value of my numbers, 4 milliamps. All right, times, and remember when we go to this side of our equation, it's what we're looking for. So what we're looking for here is our number 2 set of numbers. What am I looking for? Well, it said what percent, so I'm looking for a percentage. What is my range on percentage? Well, it's just the general numbers of 100% minus 0, because that's your lowest percent, is 0, plus 0. So here's our equation written out. This is what I want to see on your scratch paper. Now let's focus on our calculator. Looking at the calculator here, the first button we're going to hit here is open parentheses. Then we're going to do over under. We're going to punch in 5.76 minus our lower range value of our number one numbers. I was given a milliamp, so that tells me that's my number one set of numbers. And what was my lower range? It was 4. Press down to go below. Then we're going to do my upper range value. My number one numbers, 20, minus lower range value of my number one numbers, 4. Scroll over, close parentheses, times, open parentheses. Now we're doing these numbers. What I'm looking for a percent, so it's 100 minus 0, close parentheses, plus 0, lower range value of the number 2 numbers, what I'm looking for, equals 11%. So 5.76 milliamps is about 11%. You don't have to put the percent symbol. It's about 11% of 4 to 20 milliamps. Okay, now let's look at question number 2. What is the current signal in a milliamp corresponding to a signal that is 76.23% of full range? So in this case, I am given a percentage, so I can use formula number 1. And I want you to show your work, so the first thing I'm going to do here is write out my work. So since we're looking at 76.23%, I want you to write it as you would put it in your calculator. So it's 0.7623. Let me refer to my formula here. I'm going to put my upper range value of my number 2 numbers in there. So if we look at our number 2 numbers, the value I'm looking for, 2. What is the value I'm looking for? What is the current signal in milliamps? I'm looking for a milliamp. So refer to my formula. So it's going to be 0.7623 times, open parentheses, upper range value of my number 2 numbers, what I'm looking for. So it's going to be 20 milliamps minus 4 milliamps, close parentheses, plus 4 milliamps, which equals how many milliamps? So let's move over to our calculator. We're going to enter in the work in our calculator. So we're going to begin by hitting the decimal point, 0.7623 times, open parentheses, 20 minus 4, close parentheses, plus 4. And this equals 16.20 milliamps. Please forgive my handwriting. I'm trying to write with a mouse. All right, now let's work question number 3. So when you scratch paper, you'll write the problem number and then show me your work. Let's see, what is the percent signal corresponding to an 8.44 milliamp signal? So here we are not given a percentage, we're looking for a percentage, so that tells us we're going to have to use formula number 2. So let's write out our work to get started. And this is the way that I've learned to memorize it. I draw my parentheses, I put my line, put my X, draw my parentheses, put my plus symbol. Then I fill everything in. So the number 1 thing I'm going to start with, my linchpin for remembering the formula, is my process variable number 1. And remember that the P1 numbers is what's given to me. So what is given to me? The 8.44 milliamps. Milliamps. Alright, minus. So it's going to be my lower range value of my number 1 numbers. So my number 1 number, my lower range value would be the 4 milliamps. Upper range value of my number 1 numbers would be 20 milliamps minus 4 milliamps. Okay, now I'm moving over to this side of my multiplication sign. So I want to put in what I'm looking for, because remember, our number 2 numbers are what we're looking for. And what are we looking for? We're looking for a percentage. So it's 100 minus 0 plus 0 is going to equal, what is the percentage? We're looking for a percentage. Alright, let's move over to the calculator. So first thing you want to do, open your parentheses. Second thing, hit the over under button. And the first thing we're going to do is put in our process variable. Process variable number 1 8.44 milliamps. You don't have to worry about putting times 10 to the negative third in this case with the span math. 8.44 minus 4, hit your down arrow. 20 minus 4. You're going to scroll over with hitting the right navigation button. Close parentheses, multiplication sign, open parentheses. I'm looking for a percentage, so it's going to be 100 minus 0 plus 0. So our answer is 27.75%. 27.75%. Okay, now let's look at question number 4. What is the current signal in milliamps corresponding to a 0.491 of full scale? So I'm going to write out my problem. So you see here I have my problem written out. 0.491 times 20 minus 4 plus 4, because we're looking for a milliamp. Going to put it into my calculator. 0.491 times, open parentheses, 20 minus 4 plus 4 gives me 11.86 milliamps. 11.86 milliamps. Let me punch that into my computer, into Canvas. Don't worry about putting the milliamps. All right, let's look at question number 5. What is the current signal in milliamps corresponding to a fraction of the full scale, 0.664? Basically what's happening here is we're given the number in a decimal form instead of percentage, but mathematically it's the same thing. So I'm going to write out my problem. And you see here I have my problem written out, and I'm looking for a milliamp. So let's put it in the calculator. 0.664 times, open parentheses, 20 minus 4 plus 4. 14.62 milliamps. It doesn't say percentage, but it's basically a percentage because of the way it's given in that decimal format, so we can use formula number 1 on these type of questions. So I've got my answer written out here on my scratch paper, number 5, and I've got my answer in Canvas. Question number 6. What is the percentage signal corresponding to a 15.71 milliamp signal? So in this case, we're not given a percentage, we're looking for a percentage, so we're going to use formula number 2. So I'm going to write out my formula on paper. Again, this is how I write it to help my memory. I open my parentheses, multiplication sign, open parentheses again, plus, I know a number's going here, equals some answer. I'm looking for percentage. Go ahead and put that sign. So now I fill everything in. First thing I want to put in is my process variable number 1. This number can be anywhere between 4 and 20 because that's our scale. Here it's 15.71 milliamps. Okay, so I've written down my formula. I've got 15.71 milliamps minus 4 milliamps over 20 milliamps minus 4 milliamps times 100 minus 0 plus 0, because I'm looking for a percentage. Went ahead and put my percentage symbol. So let me do my calculator work. It's going to be like this. Open parentheses, over under 15.71 minus 4 over 20 minus 4, close parentheses, multiply, open it up. Since I'm looking for a percentage, I'm going to go with 100 minus 0, close parentheses, plus 0, And this tells me that 15.71 milliamps is 73% of full scale. So it'd be 73.19%. And that 15.71 milliamps would be 73% of the full scale does make sense. Because if I went to 20 milliamps, if I had 20 milliamps right here instead of 15.71, well, it would be 100% of full scale. If I had 4 here instead of 15.71, it would be 0% of scale. Now, a quick way to find 50% of scale is you add the upper range value to the lower range value, which would be 24. You divide it by 2, and that tells you that 12 milliamps is 50% of scale. 12 milliamps is 50% of scale. Upper plus lower divided by 2. 24 plus 4 is, 20 plus 20. 20 plus 4 is 24 divided by 2 is 12. So if 12 is 50%, then just looking at the number right here before I do any math, I should know and understand that 15 should be more than 50%. Matter of fact, it's almost 75%. And here's another little rough estimate for you. If you put 8, 4 is 0, 8 should be 25%, 12 is 50%, 16 is 75%, and 20 is 100%. So those numbers there, just keeping up with those basic numbers can help you. 4 is 0, 8 25, 12 is 15, 16 is 75%, so we're almost to 16. So 73% sounds right to me. Punch the numbers into Canvas. We'll go to the next problem. All right, question number 7. What is the current signal in milliamps corresponding to a signal that is 60.78% of the full range of the scale? Okay, so now we're looking for a milliamp, so let me write my problem out. Okay, so number 7, I write out all my formula with blanks. And what is the current? Okay, so I'm looking for a current. So I'm going to start with percentage inside of my formula this time. And I'm going to show you in this one how you actually can use this formula as well to find a percentage. So let me fill in my numbers. Okay, so this time I stuck with formula number 2 to find a percentage. And I've got 60.78 minus 0, which is the bottom of the percentage scale, lower range value of percentage, over 100 minus 0 times 20 minus 4 plus 4, because I'm looking for a milliamp, so my number 2 numbers are all going to be milliamps. Let me punch it into my calculator. So we're going to open parentheses, over under 60.78 minus, what is the bottom of a percentage scale? 0, over 100 minus 0, scroll over, close, open. What am I looking for? Milliamps. So let's see, 60% of full scale is 13.72. And remember, if we take 20 plus 4 equals 24 divided by 2, that tells us that 12 milliamps is 50% of scale. So 13% of scale, so 60% probably would be about 13 milliamps, because you're 60%, you're just above your 50%. 50% would be 12, so 60% probably is 13. If I ran my numbers and I got some number like 8 milliamps, I did something wrong, because there's no way that 60% of 4 to 20 milliamps would be 8 milliamps. It would have to be greater than 12, because I'm looking for 60%. So it's 13.72. Punch my numbers into Canvas, 13.72, and as soon as I submit this assignment, it'll automatically grade it for me and give me some feedback. Question number 8. What is the current signal in milliamps corresponding to a signal that is 42.79% of full range? What is the current in milliamps? Alright, we're given the percentage, so we can use Formula 1. But one thing we can think about right away is this is less than 50% of our milliamp range. So that means that it should be less than 12 milliamps. Because remember, 20 plus 4, 24, divided by 2 is 12, and that's 50%. So if we're at 42%, we ought to be at less than 12. Let's run the numbers and see. And one thing I like to do after I've written out my formula here is I like to go ahead, before I run the numbers in my calculator, is write out the value I'm looking for. What is the current signal in milliamps? So I like to go ahead and write that here. That way I know what I'm looking for, and by writing it down it helps me. So I've got 0.4279. This corresponds to my percentage, and I want to know what it is. And my milliamp range, I've already got that written in. So let's do our work on our calculator. 0.4279 times 20 minus 4 plus 4, and we said it should be less than 12. Let's see. 10.85 milliamps. I think that was probably the right answer. I feel good about it. We'll find out here in a second. Question number 9. What is the percent signal corresponding to a 5.45 milliamp signal? So looking for percent, definitely have to use Formula 2 this time, because we're not given a percentage. What is the percent signal? So we're almost down to the bottom of our range of 4 to 20. So we're almost down to 4, so we should have a very low percentage answer. So let me write my problem out, and I'm going to draw my parentheses. Equals a blank, and I'm looking for a percentage, so I like to go ahead and write that down. Alright, so the number one thing that I'm looking for, my linchpin of my memory, is this number right here. It's going to be my process variable number 1, which is the number that I'm given, 5.45 milliamps. If I can remember that this is my process variable 1, then the rest of it comes pretty easy, because it's 4, then your upper 20 minus 4. Alright, and the values I'm looking for a percentage. 100 minus 0 plus 0. Okay, so on my calculator, open parentheses, hit over under. I'm going to do 5.45 minus 4 over 20 minus 4. Scroll over, close, times, open. This is what I'm looking for a percent. and I get 9.06%. Now keep in mind, this is not milliamps, this is percent. 9.06%. And I think that's in the ballpark, just thinking about it in my mind here, because I know that if this said 12 right here, I would have 50%. If it said 8 milliamps, I would have 25%. So I'm below both of those numbers. I'm almost down to the 4 milliamps. If this said 4, I would have 0%. Getting a single digit number answer like that can be confusing and make you think you're dealing with milliamps. That's why it's critical to go ahead and write your percentage here. That way you will have it written down what you're looking for, what you're working with. Question 10. This is the final question for this assignment. What is the current signal in milliamps corresponding to a fraction of full scale of 0.885? Looking for milliamps. I'm given a decimal, which is basically a percentage, but it's already been converted for me. So I'm going to use formula number 1. Writing out my formula here. Entered my percentage number. What is the current signal in milliamps? So I'm looking for milliamps. That tells me what numbers to plug in here. So I got 20 minus 4, which is corresponding right here to the number 2 numbers, upper and lower. 20 minus 4 plus 4. Okay. And this is about 88% of scale, so should be pretty close to the top of my 4 to 20 milliamps. Let's run the numbers and see. And let me go ahead and write down what I'm looking for. Milliamps. Alright, so let's punch our numbers in. 0.885 times, open parentheses, 20 minus 4, close parentheses, plus 4. Alright, so 50% of scale, before on the numbers, let's just look at it. 50% of scale would be 12 milliamps. 75% of scale would be 16 milliamps. And we're going to be at about 88.5% of scale, so it should be more than 16 milliamps. And it is. It's 18.16 milliamps, getting very close to 20 milliamps.